determine f prime of a from this section. The next section, 2.8. Oh, I forgot to go back to this and write the title. So now we can write the title. The title is the derivative function. That's 2.8, the derivative function. And this one is rate of changes and tangents. They're both together. So derivatives, or the derivative function. That's 2.8. And the 2.7 is back to the first section, but with the limit operator. Okay, thank you for your patience with that. So I would like us to choose an f prime of a, whatever you want, and also an f prime of x from the last section of this chapter, f prime of x. And then I would like to go back and look at some examples on how to graph the derivative function, etc., etc. So, we want to choose 32. Let's do that. 4 over the square root of 1 minus x. Perfect. It is on 151. So we are given f of x, which is 4 divided by the square root of 1 minus x, and we're asked to find f prime of a. We have two definitions for f prime of a. We have to choose the one we want to apply. We can apply the one with h approaches 0, or we can apply the one with x approaches a. It doesn't matter. The answer will be the same, of course. So what do you think? Okay, very good. So if we are using f prime of a as limit as h approaches 0, let's write the definition one more time. So this is f of a plus h minus f of a divided by h. If x approaches a, then I have f of x minus f of a over x minus a. But when h approaches 0, then it's a difference quotient, but with a, not with x. Very similar, right? Easy to remember. Good. So let's continue. Can anyone give us f of a plus h?
4 over square root.
So limit. So let's copy the limit first.
H.
So we have 4 divided by the square root of
1 minus a plus h.
minus h, or parentheses, it's up to you, but one or the other. Minus 4 divided by square root of thank you very much, divided by h. Perfect. Okay. Remember two keywords that I would like you to always have in the back of your mind. What are the two keywords always? Maybe I forgot to mention. Two keywords, factor and it's L. I keep my elbow up in the air. Okay, so good, indeed. So here's what I'm going to do. I don't care for this 4. It's a factor. It will go outside. Can wait patiently till I'm done. It's a factor. It comes out from both functions, from both fractions. Can wait outside. It's one of the limit laws. Good. And now I need the least common denominator. And the least common denominator in the numerator is?
It's going to have to be the square root of 1 minus a. minus h times the square root
Of
1 minus
course, thank you very much. The square root of 1 minus a times the square root of 1 minus a minus h. They have nothing in common. They have the least common denominator has to be the product of the two. Awesome. Well done. Now I need to determine the adjustments. Remember, the numerators are just 1 right now. So I have to multiply the top of the first fraction by what it does not have, and the top of the other fraction by the top of the other fraction by what it does not have.
So it'd be 4 times the square root of 1 minus a.
4 is outside waiting patiently.
Oh, sorry.
It's okay. I don't want to involve the 4. It's not going to make any difference. And look at it, it's very patient, waiting. Okay, so obviously this is h over 1, so I have the square root of 1 minus a minus the square root of 1 minus a minus h, everything over h, the square root of 1 minus a, the square root of 1 minus a minus h. Of course, it's a mess because of the square root in the denominator, etc., etc. We are ready now to plug it in. We were ready from the very beginning, and the answer is 0 over 0, of course. We have no doubts. So if you plug it in from here, you get 0 over 0, and 0 over 0, and still 0 over 0. So which factor I'm looking for eliminating from the top and from the bottom? Eventually, not right now, I can't right now. But what is the problem that creates 0 over 0? Is it x minus 2? Is it h minus 5? No, it's
Just be h.
it has to be h. Thank you. Thank you. Of course, h is the problem. Good. So this is nice. 1 minus a is 1 minus a when h approaches 0. This, very nice. Another 1 minus a. No problem. No problem. No problem. This eventually must go away. We know that. Always. Right? Whenever we calculate and simplify the difference quotient, all terms without h eventually go away, and h from the denominator has to disappear. We know that rule from 3 weeks ago. So friendly. So I have to work on the top. That's my only hope. And how do I work on the top?
Conjugate.
Very good. That's my only chance. The square root of 1 minus a plus the square root of 1 minus a minus h. The square root of 1 minus a plus the square root of 1 minus a minus h. I will write like the lazy people, the denominator, and you'll give me the numerator. Because I only have to copy. I don't have to do anything. Not a friendly function, but thank you for choosing it because we needed to see at least one like that. Not a friendly function. So I have copied h and the square root of 1 minus a, the square root of 1 minus a minus h, and I copied this new denominator we got. But now please multiply these two and carefully tell me what to write at the top.
So 1 minus a minus 1 minus a.
1 minus a minus
1 minus.
parentheses, or you distribute one or the other. Careful. Okay, 1 minus a minus h, I agree. You have to be very careful because if you don't put parentheses or don't distribute the negative 1 from the very beginning, those terms without h will not go away. And you have to say, uh-oh, stop. I have an error somewhere, right? Okay, perfect. Well done. So it's 1 minus a minus 1 plus a and plus h, correct? So those terms indeed go away. So limit sh approaches 0, 1 minus a minus 1 plus a and plus h. And look at it, it's coming out. As it was supposed to. As we know, every time we determine and simplify the difference quotient, that h from the denominator must go away. So the top, is now just h as expected, and h from the top will go away with the h from the denominator. Should I write it one more time and not be lazy? Yes, I will. Because I don't like to simplify in a sum. I don't want you to get the impression that it's allowed, because it's not. So this is for limit as h approaches 0 from h over h, the square root of 1 minus a, the square root of 1 minus a minus h, the square root of 1 minus a plus the square root of 1 minus a minus h. And finally, it's going away. Please go away. Okay. And now we can determine the limit. We can drop the limit operator. And don't forget we have a 40 in front. So where does this go? Itself, nothing. Where does this go when h approaches 0?
1 minus a.
The square root of 1 minus a. Where does this go? Twice. So this is 4. This is the square root of 1 minus a. This is the square root of 1 minus a. And the square root of 1 minus a plus the square root of 1 minus a, which is multiplied by 2, the square root of 1 minus a. I will simplify, of course. So I have 2. This becomes 1 minus a. And this stays as the square root of 1 minus a. It was a very long problem. Any questions? Yes, please. Sabrina, go ahead.
Where did the 2 come from in the denominator?
An apple plus an apple.
Oh, okay.
The square root of 1 minus a plus the square root of 1 minus a. Questions? What does this represent? The instantaneous rate of change, or if the function is a distance, the instantaneous velocity, or derivative evaluated at a. The derivative of the function evaluated at x equals a. If you give me x, if you give me a, I'll give you a number. Okay, but just make sure you don't give me a number that is greater than 1, because I will not give you an answer. So, as you see, the function itself does not exist at 1 minus a, when a is 1, and the derivative does not as well. Okay, do we want to see another, or can we look at a function now? I would like us to understand what this is all about. So I'd like to either look at 47 or 48. Let me help you with that. To understand what are we trying to do here, and measurement units, etc., etc.
I like gold.
You want 48?
The one with gold for 47.
Oh, the one with the, okay. Okay, it's very good. So let's do both. So the cost of producing X ounces of gold from a new gold mine is C, is a function, f of x. It's the cost, but it's f of x dollars. What is the meaning of the derivative f prime of x? And what are the units? So f prime is the rate of change of cost with respect to the number of ounces of gold, right? So always remember the derivative has to have 2 measurement units. Is the rate of change. When I drive and you call me and say, hey, tell me your instantaneous rate of change, I will say 60 miles per hour. 2 measurement units, one coming from the top unit, or the top, yes, the measurement unit of the top variable, over the measurement unit of the bottom variable. So here we're talking about the rate of change of cost with respect to the number of ounces of gold that we collect. So the measurement unit will be, one more time, dollars per ounce. The rate of change of cost, which is in dollars, over the number of per ounce. Right? So I don't want to switch right just this moment. I'm going to write it in a moment. What does this statement f prime of 800 equals 17 mean?
Would be 17 ounces of gold.
When, so, careful,
It costs
which is this and which is this? What does this represent?
Dollars.
Careful.
No, that's ounces.
So f of x is in dollars. So the function is in dollars, not the inside, right? So the independent variable is number of ounces, x, and the dependent variable is cost. Okay? So this is the cost in dollars, and this is the number of ounces that we, whatever, purchased. So the rate of change immediately after 800, or 800 if you want, the rate of change of cost per ounce when we extract 800 ounces is 17. It predicts the cost of the next item. Is that clear? So the rate of change when we extract 800 ounces is 17. What is the measurement unit? Dollars per ounce. So when we extract 800, the rate of change is $17 per ounce. Do you think the values of f prime of x will increase or decrease in the short term? What about the long term? Explain. So in short term, they will increase, right? But long term, the more ounces we extract, the price per ounce decreases. Any questions on this?
So it's kind of like wholesale.
Right, exactly. You buy in bulk, the price per unit is less. Correct. Okay, let's look at the experiment of bacteria in the lab. Okay, so the number of bacteria after T hours in a controlled lab experiment is, this is the number, this is the function that is the number, and this is the time T. T in hours. T is time, this is the number of bacteria. What is the meaning of the derivative at prime of 5? And what are the units? You have to give me 2 units, one from the top and one from the bottom. So what is the meaning of the derivative at prime of 5? At, right,
How many bacteria?
that would be the rate of change of bacteria at that instant, right? After 5 hours, f prime of 5 gives the rate of change of bacteria at that instant. What is the measurement unit? Number of bacteria per hour. That's the rate of change. F prime of 5 at 5 hours into the experiment, the rate of change of the number of bacteria per hour is f prime of 5, right? Bacteria per hour. Suppose there is an unlimited amount of space, nutrients for the bacteria. Which do you think is larger, f prime of 5 or f prime of 10? If it's unlimited, they can grow exponentially, very, very fast. F prime of 10 is definitely bigger because they multiply tremendously, very fast, right? So which do you think is larger? F prime of 10 will be larger than F prime of 5 because they got momentum and they grow and grow and grow. If the supply of nutrients is limited, would that affect our conclusion? Yes. Let me give you an example. Let's say we bring in this room all of a sudden 50 people. They come in fast, and the rate of change of number of people in the room increases fast. But then when we get, let's say, to 100, we can't push more people in. It's going to take, the rate of change will be much less. Maybe we squeeze in 1 more, maybe 2 more, but then it's limited because we can't bring in more than X number of people. So the supply of nutrients is limited, then f prime of 5 is bigger than f prime of 10 if the supply is limited. F prime of 10 cannot get in anymore. There is no more room. Not 10, but you know what I mean. So it depends. If it's unlimited, of course, this is the fastest growth between the two, rate of change. But if the supply of nutrients and the location and whatever, they can multiply that fast, then this is faster than this. Okay, any questions on this? I would like to look either at an f prime of x. You tell me. There's an f prime of x here on page 163, f prime of x, or we look at a graph, or both. I mean, we have time, yes, 20 minutes. We have time to work on an f prime of x. I recommend maybe a rational function or something else you want. And then we're going to, step by step, given a function, graph its derivative. It's going to be an approximate graph. Now, it's not going to be 100%. But we want to look at 30. Okay. It's another radical, but that's fine. I was hoping for a rational function this time, but we can do both. Yes, of course. We should do both. Perfect. So we started with 30. And this is on page 163. This completes, after we graph a derivative, etc., and some other, completes chapter 2. Everything is done from chapter 2. So 30 on 163, and it's f of x equals x to 3/2. Perfect. So this time we're asked to find f prime. Here we have no choice. We only have one definition for f prime of x. Okay, how do I start? And we should, moving forward, we should always remember is the limit of the difference quotient. We should never have any difficulties with f prime of x. So what do I have to write?
Limit at h quotient 0.
Let's write the definition first, because we have to write it a few times before it really gets embedded in our system. And now I have to plug it in. Always remember a fractional exponent can be replaced by what type of expression? Excellent, very good. So this is the square root of x to the third. Good. So this will be then the square root of x plus h to the third power minus the square root of x to the third divided by h. Of course, when you plug it in, what we are going to get, always, for the limit of the difference quotient, 0 over 0, of course. Good. So then let's see how we proceed. What is our only option here? Of course. Well, yes, of course, the conjugate. It says our only option. X plus h to the third plus the square root of x to the third over x plus h to the third plus the square root of x to the third. Perfect. So this is limit as h approaches 0. H is the denominator. X plus h to the third plus the square root of x cubed. Can anyone give us the numerator? I wrote the easy part, and I want you to do the heavy duty. What do I write?
It's just x plus h cubed.
Yes.
No, okay. And then minus x.
Yes. I recommend here using the difference of cubes. If you do not use the difference of cubes, then you would have to raise x plus h to the third power, and you would have to get 4 terms. Which one would you like to approach? I recommend the difference of cubes.
Let's do it.
Okay, so let's do difference of cubes. Let me refresh our memory. Should I refresh our memory on the difference of cubes? Yes? So it's a cubed minus b cubed equals a minus b. A squared plus ab plus b squared. Notice that this is a and this is b. Careful. So then we have limit as h approaches 0. So a minus b, x plus h minus x. Now a squared, do not square it. Plus x plus h times x, or x times x plus h, do not distribute, plus the last term squared, which is x squared. Maybe for you to see it better, maybe I should put brackets here instead of parentheses. They are nested parentheses, but maybe it's better if I do that. I forgot to ask you, since we get 0 over 0, which one is the culprit? Which factor has to go away eventually?
H.
Of course, of course. You always see it here, h minus 0, so it's h. Perfect. So look at what happens. The negative x with the positive x will go away, and obviously the positive h with the positive h will go away. So now, when h approaches 0, where does this go? Just this.
X squared.
Squared, excellent. Where does this go? Just this.
It'll also be x squared.
Perfect. Plus x squared. How much is x squared plus x squared plus x squared? 3x squared. And now about the denominator. Where does this go when h approaches 0?
X cubed.
The square root of x
Square
cubed
root of x cubed, yeah.
plus the square root of x cubed. An apple plus an apple is 2 apples. And this is it. It would have been a little bit longer if you did not remember the difference of cubes. You would have had to cube that, and you get 4 terms. I can give you that formula as well if you'd like, but I don't recommend it here. So we have a plus b to the third power is a cubed plus 3a squared b plus 3ab squared plus b cubed. If we have minus, the signs alternate. So minus here means minus here and minus here. Okay. Any questions on this problem?
Wait,
Yes.
Can you explain how you got the 2 square root x right in the bottom?
The denominator. When h approaches 0, I get the square root of x cubed plus the square root of x cubed. That's okay. Okay. You also said 29, was it?
Yeah.
Okay, 29. 29 is g of t equals 1 minus 2t divided by 3 plus t. Before we do that, let me go back and ask you, do we have any questions on the previous problem? Any questions? Is everything okay? You need to practice this because you understand it now, but it's a difference between understanding it and reproducing it. Okay, here we are asked to determine g prime of t. Let's write the only definition we have for g prime of t. And that is
When that h goes, we got start with the definition like we did before, so.
Yes, so let's write then in this case, g of t plus h minus g of t over h. Instead of f of x plus h, we have g of t. So we use g of t plus h minus g of t over h. So from here, I have limit, sh approaches 0. Can anyone dictate the numerator?
1 minus
Yes?
2t plus h.
Yes, but you have to use parentheses or you go ahead and simplify. So it's one or the other, right? So t plus h, because t is t plus h. So when you distribute -2, we say -2t minus 2h. It's better to do it in one step if we can. If not, just write parentheses and come back to it. And now minus g of t, which is 1 minus 2t over 3 plus t divided by h. And now please tell me how to continue.
Least common denominator.
Excellent, yes, thank you.
So that would,
Of course, they have nothing in common. They both have to be in the least common denominator. 3 plus t, 3 plus t plus h. Now be very careful because of the adjustments that the first fraction gets a 3 plus t. And the second fraction, this is not a good color, sorry. So 3 plus t. And this one gets a 3 plus t plus h. See why I insisted that we're able to simplify and determine and simplify the difference quotient? And we know two things have to happen, right? What are those two things that have to happen?
Factor and simplify.
All terms without h from the top will go away, and eventually,
the h from the bottom must go away.
yes, correct. Perfect. Without the limit, there will still be an h left in there at the end, but now because of the limit, h will go away completely. Okay, so I'm distributing 3 to these three terms. Of course, you know I'm going to run out of room in a second. So this is 3 minus 6t minus 6h, and plus t minus 2t squared minus 2th, and then minus 3 minus t minus h plus 6t plus 2t squared plus 2th. It's not that I ran out of room, I ran out of room twice. So minus 3 minus t minus h, yes, and then plus 6t, 2t squared, and 2th. Okay, remember all terms without h must go away. If more go away, it's a bonus, that's fine. But definitely the positive 2t squared with a negative 2t squared. The positive 3 with a negative 3. The positive t with a negative t. Luckily, 2th with negative 2th. 6t with a negative 6t. Good. So this is left and this is left. Nothing else. Just two terms. Negative 6h and negative h. So that's a negative 7. So now, limit as h approaches 0. Negative 7h over, and now I'm going to flip the denominator. H, 3 plus t, 3 plus t plus h. And we know what happens next. This is exactly what we've been waiting for, which is the second step. The first step, all terms without h are gone. Bonus, some terms with h are gone as well. Good, that's good for them. And now the second step, or the final step if you'd like, h from the denominator will go away. As we expected, as we know for 3 weeks already. And now the limit operator is gone because I apply it. It's like when I determine the square root of 9. The square root of 9 is not the square root of 3. It's the square is 3 directly, right? So the numerator goes to Negative 7, the denominator goes to,
3 plus b.
that's it, thank you very much. That's it. Okay, we have about, what? 6 minutes left. I would like us to look at a graph. Very good questions you brought today to class. Thank you. Okay. So let's choose a graph and graph the derivative. Okay, it says trace or copy the graph of the given function f, then use the method of example or whatever to sketch the graph of f prime below it. So let's choose one. 7, we want to choose 7, very good. It's an approximate graph, it's not going to be identical. An exact graph, I meant to say. 7 on page 162. And here's the graph of 7. Please leave room underneath the graph of the function, right here. Okay, identical, the vertical, the y-axis has to be one, the two y-axis have to be one under the other, please. Okay, so here's number 7. It's a semicircle. Okay, ready? So I'm going to pick some points. Of course, I'm going to look at this point. I'm going to look at this point. I'm going to look at this point. And I'm going to choose, let's say, maybe this point as well. And maybe one on the other side. And definitely this point, which is on the y-axis. Okay. At all these points, I'm going to draw the tangent line. At all these points, I'm going to estimate the slope of the tangent line. Okay, so let's start with the easy one, right here. I'm going to draw the tangent line, and I'm going to ask you what is the slope of that first tangent line that we drew? 0. On this side, this is my second point that I would like to draw the tangent for. So I'm going to use a different color. Is this a positive number or a positive slope or a negative slope?
Negative.
Of course, it's a negative slope. How do I estimate this? I don't know. I'm just going to draw a right triangle. I don't have a grid. I can't. It's very difficult, right? So I'm going to say maybe this is 2 units and maybe this is 1. So rise 1, run 2. So the slope of this is negative 1/2. At this point, if this is 1 and negative 1, negative 1/2 is this point will be this point. So at this point, at this x coordinate, if you want, I determine the slope of the tangent line. How? Approximate. I know it's negative. It's somewhere between negative 1 and negative 1/2, roughly. So I created a right triangle. I said this is the rise and this is the run. I estimated this to be 1. I estimated this to be 2. You may say, well, it kind of looks like 1, 1. Fine. I agree with that too. So I said it's negative 1/2. And if this is -1, then this piece is -1/2 of this value. This value, -1/2. Okay, I move on to this one on this side. I draw the tangent. I don't want to find it as symmetric, so I'm going to move a little bit to the left. I don't want a symmetric. I already found -1/2 here. So let's say here, this is my tangent. I'm going to estimate it. I'm going to draw a right triangle. I'm going to say this appears to be kind of 2/1. Is this a positive slope? Yeah, so the slope here, I would say, is 2/1, which is 2. For this particular point, right here, I'm going to plot +2. So I found 3 points. One, which is 2, one, which is 0, the other one, which is -1/2. And now I'm going to, you can, if you want to go here, let's say, obviously from this point, the slope is decreasing, right? So it was 2 here. Obviously, it gets to 0, and then it continues to be negative. And here, what happens at these points? There is no slope. The function is not differentiable at these points. They're like cusps, right? And besides, what is, or if you want, you can even say it is like a vertical tangent, right? There is no derivative there. So obviously, the closer I get to this point, the higher the slope. So here, it's, I don't know, 5. Closer is 10. So it really is something like this. And it's going down. And then continue to go down. And I will say the derivative does not exist at those points. So it starts with a huge value, high value. I don't know how high, but I know it's not defined here. It's not differentiable here at this point, so then it's an open point. I know it's positive all the way, but it drops to 0. And then it continues the slope to be negative at all times. That's why it goes down to a negative and never comes back. And this is an approximate graph, of course.